Okay, good morning all of you. My screen is visible. Hello. Anybody? My screen is visible.
Yes, sir.
Okay. Ask them to join others also. I think attendance is poor. Okay, we'll see the types of choppers today's class. As we discussed in the previous class, there is a step up chopper, step down, up and down chopper that is based on the supply voltage variations, or you can say that load voltage more than the supply, it is a step up, less than the supply, step down, like that. And other classification based on the quadrant operation. In a quadrant operation, we can divide these choppers class A, B, C, D, E. So these are the different types of choppers based on the quadrant operation. Now we'll see one by one. The first one is important one. There is a class A chopper, or also called as a step down chopper or a first quadrant chopper. Now this is the circuit in class A chopper or a type A chopper. The thyristor, it is nothing but a step down chopper only. Diode, then inductor connected to the load. So now this I call it as a first quadrant chopper. So why we call it as a first quadrant chopper? We'll see that operation. For all the choppers, operation is fixed as I told in the previous class. Chopper is on. Another one is chopper is off. If we identify these two scenarios, we can easily understand the operation. First one, chopper is on. If chopper is on, what will happen? This will on, means thyristor will conduct. Then what is the current? Current will flows like this. It goes to the inductor, goes to the load, then to the source. Then what is your output voltage? Output voltage same as the supply voltage. So that is equal to VDC. And inductor will store the energy like this. So this is the instant when chopper is on. Next one, when chopper is off, then what will happen? When it will on, when it will be off, that is two instants. When you are giving as a firing pulse, chopper will be on. And if you disconnect the firing pulse, chopper will be off. During that instant, if no firing pulse is available, means in turn forced commutation is going to be takes place and chopper is going to be turned off. And now if the chopper is off, that means this is open. If chopper is open, then what will happen? This is minus, this is a plus. The inductor is going to dissipate energy, and when the switch is open, then what will happen? Minus is directly connected to the cathode of a diode and plus is connected to the anode of a diode. Therefore, what will happen? You can see diode is going to on. If diode is on, then how the current will pass? Now you can see that plus it goes to load, then it goes to the diode and it will flow like this. Then what is your output voltage? Output voltage is 0 because diode is short circuited. If diode is short circuited, then output voltage is equal to 0. And what will happen? The current, whatever energy stored in an inductor is going to be dissipated through diode and load. That's why current will be gradually decreasing. Whereas earlier current will be gradually increasing. When the chopper is on, current will be rising, and chopper is off, current is decreasing. Again on, again off, like this. This is the current waveform. Now the procedure is that very simple, two steps. When chopper is turned on from 0 to T on instant, The current will flows through the source, chopper, inductor, load to the source. Then output voltage is equal to the same as the source. And when chopper is turned off, whatever energy stored in an inductor, it is going to be dissipated through diode, because diode is forward bias. Then output voltage is equal to 0. Then current will pass through the diode. So therefore current will be decreasing because of the energy stored in inductor is going to be dissipated. That's all. So that is only the operation or explanation. Now what we want to do is you have to find, we will see that waveforms also, because as I said, now first you have to give the firing pulse, then output voltage, current waveform, thyristor, diode waveform also you can draw, and step by step the derivation part also we need to do. Now we can see here, once given as a firing pulse, this is a firing pulse. From 0 to T on, pulse is there, then output voltage same as the source voltage, and current will be gradually rising. That is the first instant. See that I am providing the pulse T on duration, then output voltage same as the source voltage, current will be gradually rising. Then thyristor is going to be turn off. How the thyristor will be turn off? Because we are disconnecting the firing pulse. Here no pulse during off instant, and the output voltage is 0. Why output voltage is 0? Because diode is conducting. If diode is conducting, automatically load is short circuited. That's why output voltage 0, and current will be gradually decreases. And again pulse is given, then the current will be gradually rising, and output voltage same as the source. This is the waveform. Once if you give the firing pulse to the chopper and withdraw the firing pulse to the chopper. So in that instance, we can see that waveform will be like this. Now another instant you can see, if I given off duration is large, then what will happen? Here you can see that when compared to on duration, off duration is small. Now if I given off duration is large, then what will happen? For that you can see the waveform. On duration is small and off duration is large. So whenever on duration is there, operation is as usual of previous only. If the chopper is on, output will be same as the source. Then if chopper is off, then what will happen? This current gradually decreases and it reaches to the 0, because whatever energy stored in inductor, it is going to be dissipated. Once energy is dissipated completely, then if you are not fire the device again, then what will happen? This current will be remains in the 0 only. Current will be remains 0, but what about the voltage? Because there is a load consisting of some motor, let it be some back EMF or a battery source. For all the case application, drive application only, that's why let assume that load having some motor, their back EMF or a battery, let it be some battery. Then the chopper is turned off at this instant, then what is the voltage across the load? Whatever battery voltage or a back EMF voltage. That's why I mentioned here the 0 point, because the diode is turned on. Once diode is off, when the diode is going to be turned off? Whenever energy stored in an inductor is completely dissipated, then the no current pass through the diode, automatically diode will be open. Very simple logic. See that chopper is on, then what will happen? If chopper is on, current pass through the inductor and load, then output voltage same as the source. And chopper is off, this is off, then what will happen? Whatever energy stored in an inductor, it is going to be dissipated through diode. Then your current waveform will be like this. Current pass through the diode. And after some instant, that current also reaches to 0. Now you can see this current is also reaches to 0. Then what will happen? At this instant, diode also going to be open here, diode is open. If diode also open, then what will happen? No current pass through the device because already chopper is off and diode is off. The current will be remains in the 0 instant. During this instant, the magnitude is E or a EB battery or a back EMF if motor is connected to the load side. Then after that again on period, after off period is completely over, then again there is a on pulse. If pulse is there from 0 instant, again it rises to maximum. Again what will happen? There is off. Then current will be gradually decreases to 0 and remains in the 0. And again if pulse is there, it will be turn on again like this. So this is the difference between continuous mode and discontinuous mode. In a continuous mode, current will be start from minimum and reaches to the maximum. Again it decreases to the minimum and maximum. This is the instant. In a discontinuous mode of operation, whenever this off duration is large, then the current will reaches to the natural 0. It becomes as a discontinuous mode of operation. In a discontinuous mode of operation, this current will be reaches to the natural 0. So this is the different. In that case, when the discontinuity will occur, very simple logic. If I minimum is equal to 0 over, see that I can see here this reaches maximum and decreases to the minimum. If this current go on decreasing like this, then at some point of time it reaches to the 0 and remains in 0. This point I call it as a discontinuous point. So that means if I minimum is equal to 0, then I call it as a discontinuous mode of operation. So this is the case of the on period is more or off period is more. If off period is more, we will get as a discontinuous. We will see the small derivation also. In the discontinuous mode of operation, when the chopper on time is less than the off time, then the load current increases exponentially during chopper is on and becomes 0 during chopper is off. That's what we call it as a discontinuous mode of operation. Once the chopper current is 0 and then the chopper is off, then the inductor current also reaches to the 0 and the diode is going to be turned off and remains in the 0 state. That we call it as a discontinuous mode of operation. On time is less than the off time, then automatically it goes as a discontinuous. Continuous means what will happen? The on time will be greater than the off time. Current will flows through the load. The load current increases exponentially during chopper is on and decreases during chopper is off. So that's what I mentioned the current waveform also. When we can see that the current waveform, current when chopper is on it will be increases, chopper is off it will be decreases, again on again off like this. The current waveform nature will be when the chopper is on, inductor will store energy, current will be increases exponentially and the chopper is turned off, current will be decreases. That is what, and on time is greater than the off time, then we can say that it is a continuous mode of operation. Now, I want to know what is the value of I minimum and what is the value of I maximum, because I mentioned here some magnitude this and this is a magnitude of maximum. So we need to derive the expression for I minimum and I maximum. So that is the very important derivation. Even in the dry subject also they ask that derive the expression for I minimum and I maximum. Now during continuous mode of operation, you can see that in this mode of operation, when the chopper is on, what is our voltage equation? You can see your circuit also. By seeing your circuit, there is a supply, then chopper, then what will happen? Diode, then inductor, then load. This is your circuit. When chopper is on, what is your voltage equation? This is a VDC. Current flows through like this. Then what is your equation? VDC is equal to, there is a, consider load is a motor, then R, L, E, all the things are there. Then what will happen? VDC is equal to Ri plus LdI by dt plus back EMF. That is the voltage equation when chopper is on. When chopper is off, what is the voltage equation? The diode is going to be forward bias. If diode is forward biased, inside this is a voltage equation. Then what is your voltage equation? Ri plus LdI by dt plus back EMF is equal to 0 because it is short, no? Output voltage is equal to 0. What we call it as diode is short circuited, because you can say the diode is forward biased, then the load is short circuited, then output voltage equation Ri plus LdI by dt plus Eb is equal to 0. So these are the two instant. Now we'll see the step by step derivation for I minimum as well as the I maximum. When switch is closed means chopper is on, and the interval is what? This is 0, this is a on period, end of this, then again off period. So during the instant 0 to turn on, that is the instant. What is our voltage equation? Voltage equation VDC, that is equal to R into I or I naught, whatever notation you can follow, R into I naught plus L into di by dt plus Eb, that is equal to VDC. From this what I want? I want current. So how will you get the current? You can use current is a either you can use complementary function and particular integral, or you can see that Laplace transform and then inverse Laplace transform, you can get it as a current I. So now you can see the current I is equal to, there is a complementary function is equal to something constant into e power minus r by L into t. So this is the complementary function RL load. We can see that current I is equal to some constant K or A or B, anything you can use it, no issue in that, just constant K into e power minus R by L into T plus VDC by R minus EB by R. This is a current expression from this. But in that, what are the parameters are known to you? You know VDC, you know R, you know back EMF, RL, everything is known except the K, K1. That constant you have to find. In any equation, how will you find the constant? By substituting the initial condition. What is the initial condition here? Our intention started this duration, I started the derivation 0 to t on interval. This is a on interval. During that, first t, this is x-axis is t. So t is equal to 0. What is the current? I is equal to I minimum, and substitute there. So I is equal to I minimum. You can substitute initial condition in that equation. I is equal to I minimum, that is equal to K1 into E t is 0. E power 0 is 1. So K1 plus VDC by R minus EB by R. From this, what I can write? K1 is equal to I minimum minus VDC by R minus EB by R. I am taking this. This is a K1. Now you got the K1 and substitute K1 in again in the same equation. Then what I can write? I is equal to K1. K1 is nothing but I minimum minus VDC by R minus EB by R. This is the total K1 multiplied with what? E power minus R by L into T plus, what is this equation? As usual, VDC by R minus EB by R. So this is the equation after substituting as a K1. And you want to can simplify further also. This e power minus R by L you can multiply inside here and take this factor is common here and here. So you can take it as a common factor. VDC by R minus EB by R is common. 1 minus e power minus R by L into T. Suppose if I take the common, still you can see here, I will show otherwise. So if I take common and simplify that, you will get it as a, this is the K1, and then I is equal to I minimum minus this plus this, and you multiply inside this factor. Therefore I is equal to, what I can write here, I is equal to I minimum into e power minus R by L into T and plus VDC by R minus EB by R, you take it common. What else? 1 minus e power minus R by L into T. This is the expression. And another initial condition is what? First initial condition, T is equal to 0, current I is equal to I minimum. What is another initial condition? T is equal to T on. What is the current? I is equal to I maximum. See that T is equal to T on duration, current I is equal to I maximum, and substitute that. So I is equal to I max, that is equal to I min into e power minus R by L into T, that is T on, and plus VDC by R minus EB by R into 1 minus e power minus R by L into Tn. This is the equation 1. I want I minimum value and I maximum value. For that, two unknowns, no, you need two equations. So one equation I have I max is equal to something in terms of the I minimum only. Again, you will get it another equation in terms of the I minimum and I maximum, and solve these two equations. You will get it as a what is the value of I minimum and I maximum. So now I substituted another initial condition T is equal to T on, I is equal to I maximum. You will get it as a equation 1. This is the equation 1. You can see this. There is a equation 1, I max is equal to I minimum into something. This is one equation. And second, you can see that another interval. What is the another interval? You can see here. First interval I taken 0 to T on. Then what is the next interval normally? You can see that there is a T on to T less than capital T, because this instant is a capital T. Finally, this duration is a T on plus T off, that is a capital T. Or else, another way also you can do same fashion. Instead of using again T on and then capital T, all this thing, you will simplify this interval. From this point, I take it as a reference now from here to here. What is this duration? Here to here is a half duration. So I consider this is a T dash, then 0 less than T dash less than T off. T off I can write T minus T on. This is the interval I want to derive the expression. So 0 to T off, because 0 to T on I derived, then up to this duration I call it as a T off. So that T we started, this is a reference now, I can consider T dash. So 0 to T off means T minus T on. What is the voltage equation? If this voltage equation is again same, what I can write? Ri plus L di by dt plus EB, that is equal to 0. Instead of VDC, now when the chopper is off, you will get it as a 0. And same thing you can derive the expression. Now you can see the interval I taken 0 to T minus T on. Then the voltage equation is this one. From this I is equal to, what I can write? I is equal to here only one particular integral. Earlier we have two particular integrals, complementary function, and now complementary function as usual, and particular integral is only one. So minus EB by R. So then what I can write? Current I is equal to something, another constant K2 e power minus R by L into T dash. Now I consider T dash minus EB by R. That is a current. Now how will you get the K2 now? Again substitute the initial condition. What is the initial condition? T dash is equal to 0. What is the current? This is a T dash. This T dash starting point and ending point is this. Two initial condition. First initial condition at T dash is equal to 0. What is the current? Current I is equal to I max. This is the maximum. Later it will be minimum. Then substitute I is equal to I max, that is equal to K2 e power minus R by L into 0, that will be same as K2 minus EB by R. Now from this K2 is equal to, what I can write? K2 is equal to I max plus EB by R. This K2 again substitute here. Then we'll get it as a I is equal to I max plus EB by R. This total I call it as a K2, and then e power minus R by L into T dash minus EB by R. And again you can simplify it this way and take common. Minus EB by R is common. Then 1 minus e power minus e power minus R by L into T dash will get it. Again another initial condition. What is another initial condition? T dash is equal to, this is a T dash is equal to T minus T on. Current I is equal to I minimum. You can see that this is a t minus t on interval. What is the current? I is equal to I minimum. And substitute this initial condition in this equation, then another equation will get. So we'll get two equations and two unknown. We can easily solve. That's all. Very simple logic. We'll take chopper is on, what is the voltage equation, and chopper is off, what is the voltage equation. Now we can see that K2 we got it, and substitute the K2 in the previous equation. We'll get I max into this minus EB by R taken common is this. And again another initial condition we have to substitute. T dash is equal to T minus T on, I is equal to I minimum. You will get it as a equation number second equation. Now you have two equations. What is the two equation? Earlier one equation we have I max is equal to I min into e power minus r by L into t. So that equation and plus and so on. And this is a I max is equal to I min is equal to I max into e power minus r by L into t minus t on. So this two equations and two unknown. What are the unknown? I maximum and I minimum. So you have to equal. What I will do is either equation 2 substituted in equation 1 or equation 1 substituted in equation 2. You can simplify. We'll get it as a one value first. Then that value either I minimum or I maximum. That value you can substitute in any one of the equation. We'll get it as a second equation. That much simple. Now we can see that I am doing equation 2 in equation 1. Now we can see equation 1 is I max is equal to I min into something. So I min equation is nothing but a equation 2. You can see that this one is a second equation I min. Entire equation you substitute in this I min into e power minus r by L into t on plus this previous equation 1 equation. Exactly what I am doing is, you know, two equations. I am simplifying the two equations. So now I am substituting second equation in first equation. First equation is what? I max is equal to I min into e power minus r by L into t on plus this. So only this I min value is there in the equation 2. That I substituted here. That's all. Nothing is different. So now what we have, something cancel out parameters. You can cancel it. You can see I'm simplifying e power minus r by L into t on. I'm multiplying inside here. Then what will happen? The splitting, you can see that there is a, just I will write here, e power minus r by L into t into e power minus get plus r by L into t on. And if you multiply this outside e power and this into e power minus r by L into t on, then what will happen? This will get cancelled out and only e power minus r by L into t will be there. That's why we are getting this point here. And then similarly you can see that e power minus r by L into t on, and in this side if I multiply inside this, what will happen? Minus get plus, and this minus term, this plus term will get cancelled out. So like that, just I simplified that. Finally we got it as I max is equal to, this is the expression. So we got one expression by substituting equation 2 in equation 1. I got I max is equal to. So I max is equal to this one. Once if I know I max, let it be this is equation 3. You substitute equation 3 I max. Where I have to get it? Substituted in equation 2. I max you can substitute it in the equation 2. You will get it as a, what is the I mean? That's all. That is more small derivation. Now you can see that equation 3 substituted in equation 2. Then you can simplify this I min is equal to I max into something. That I max value already you know that you can write it here. And simplify, you just multiply again same as inside this factor. You can multiply inside and simplify this. I can split like this also. E power r by L into t on divided by e power r by L into t. The minus term is there, minus r by L into t. I will write in denominator, it will be r by L into t, and minus get plus here, e power r by L into t on I will write in the numerator. And this total factor you multiply inside, then these terms will get cancelled out here, and finally we'll get it as a, this is the parameter. and or this way also you can write, anything is same because minus minus cancel out. No? So I maximum and I minimum, this is the I minimum and previous expression is I maximum. So this is very important. Explain the basic chopper or step down chopper or first quadrant chopper and derive the expression for I minimum and I maximum, and then you can see the discontinuity mode of operation. So what I can, when the system is going to be discontinuity, I told no, in the as per the current equation, you can see that current waveform is rising like this and decreasing, rising like this. So this is a I min and this is I max. If I minimum reaches to the 0, that become as a discontinuity. It is go on decreasing and finally reaches to 0. No, that is a discontinuous. Therefore, I min is equal to 0. I call it as a discontinuity condition. So now I min is equal to 0. You have value of I minimum. Previous equation, you can see this is your I minimum. So this value is I minimum. You equate it to 0 and then you can simplify, this is equal to 0. You can see this point is 0 and what will happen, RR will get cancelled, then this point is equal to EB by VDC, that I call it as a G, and you can simplify this R by L into T on and divide both sides by T, then what will happen here and here, if you divide by T, T on by T is equal to delta. So that I call it as a new delta, delta dash is equal to this one. So if your chopper operating delta is del, now this according to our relation, you got a delta dash expression. If delta dash value is more, then automatically you call it as a discontinuous mode of operation. So if delta is less than delta dash or delta dash is greater than delta, then we call it as a discontinuous mode of operation. They may ask that problems also, if they may give some data and they may ask you find whether the system is continuous mode of operation or a discontinuous mode of operation. In that you know the delta value, they may give in the delta, or you can find the operating delta. Now use this formula and substitute whether this delta dash means original delta is less than delta dash or not. You can check it. If it is less than delta dash, then you can say that it is a discontinuous mode of operation. Otherwise, it is a continuous mode of operation. So that is the one important. Now another equation waveform you can see here. I want to find average current. Here the current you cannot directly divided by R. You know the average voltage. What is the average voltage? V out is equal to VDC into delta here. So now this current waveform, you can see that in this case it is varies exponentially, and that is the reason you can see that these two currents are different. This current is carried by the chopper and this current is carried by the diode. Now I am splitting these two currents separately. During on condition, chopper current is there. During off condition, chopper current is there. So that's why what I am doing is I split these two waveforms separately. I will write the current waveform like this. Nothing is there, just wherever exponentially rising, that current carried by the thyristor, and decreasing current carried by the diode. So in that fashion, I am writing separately. This is the chopper current, and then off duration chopper current is 0, and again it is rising. Then this is 0 and rising. This is for chopper current. Similarly, when the chopper is off, then what will happen? Then this current will be gradually decreases. So this current will be gradually decreases. Then what will happen from maximum to minimum? This current carried by the diode, and again during chopper on, diode current will be 0. During chopper off, diode will be on. This is the current. Now what I want is, I want to find the average output current. I want to find I naught. Then how will you get the I naught? This is nothing but a IT average plus ID average. I out average will give sum of these two averages will give as a IT average. How will you get the IT average? You take one full cycle, this duration, and integrate it. And IDF also, you take one full cycle and integrate it. So in this case, here current is there, you just integrate only on period and this will be 0, off period is 0. Whereas in the diode case, on period will be 0 and off period will be, you can integrate this wave. What is the integration also? Limits, you can see that here the limit is minimum to maximum and here limit is maximum to minimum. So just I am doing integration of one full cycle for thyristor as well as the diode. So in that case, you can see the expressions for what I am doing. Chopper is on, then the average thyristor current I am calculating, and chopper is off, diode will be on, average diode current is going to calculate. Now we'll see that when chopper is on, what is your voltage equation? Voltage equation is known to you in the previous derivation part. VDC is equal to, chopper is on means current carried by the chopper. That's why instead of I out, I will represent this is IT. Whereas diode is on, I will represent as ID. That is a diode current, like that. So VDC is equal to RI plus LDA by dt plus EB. Now this EB I will write this side. So therefore EB minus VDC minus EB. This dt I will multiply this fashion, just cross multiply dt, that is equal to R into IT dt plus L dit by dt, that EB is already in this side. Then what will happen, you can see now I want to integrate. So why I want to integrate? To get average. What is the interval now? You can see that from 0 to T on. In this diode chopper case, 0 to T on is your interval. Whereas in that case, T on to T. That is the case of diode case. So now limits also, you can see that this limits is going to minimum to maximum, min to max, whereas other one is max to min. So that you can take care, and remaining everything is same. Now you can see this. What I am doing is just integrating 0 to T on portion, and now that this portion is average the chopper current, I can represent this 1 by T into T on 0 to T on I dt, that is a IT average, and this 0 to T on the inductor current is varies linearly. You can see that exponentially, I minimum to I maximum. Then substitute that, you will get it as a what is the average thyristor current. Now I want output average current. So now I know IT average. Similar fashion you find IDF average. You can add these two, we'll get it as this one. So now we'll go for as a diode. Diode case, what is the different? Nothing is different here. VDC place is 0 and IT here you can use as a DF or something current. And that simple fashion again you integrate this, but limits will change and we'll get it as a what is your freewheeling diode current. Now you can see 0, IDF same manner, nothing different, but limits are changed. 0 to T on earlier, now T on to T, and that exponential decaying also, you can see that from maximum to minimum. So earlier it is a minimum to maximum, the limits is now maximum to minimum. In that small changes if we do, this is a maximum to minimum, and finally you will get it as a IDF. Just see that this portion is, I call it as a freewheeling diode average, and you can change over from 0 to T on to T is nothing but I max to I minimum, and integration differentiation will get cancelled out here, and you will get it directly minimum minus maximum, and this is a IDF. And you can add now. By adding these two, we can get it as a what is the average current. Now we got average current is equal to, this is the total output average current, V out minus EB by R, final expression we got it. So this portion I call it as a thyristor average current, this portion I call it as a diode average current, and now you just minus terms will get cancelled out here, and finally we'll get it as V out minus EB by R. What is V out? V out is nothing but a delta into VDC, and V out minus EB by R is your average thyristor current. Earlier in normal cases and all, once if you know V out, I out is equal to V out by R, will write like that. But now because of this motor equation, back EMF also will present V out minus EB by R, that is your current, average current. Now this is about class A chopper. Now we'll see class B chopper. What is the class B chopper? Again only the variation is device connections, something like. You can see earlier diode is in this side, in the parallel, and switch will be in the series. So now we replace that into like this. This also called as a step up chopper. Whatever we discussed in the step up chopper case, same thing. Now we can see here again two logics. Chopper is on and chopper is off. So once if you understand this small logic and any circuit, you can draw the waveforms or a derivation or everything. Now we can see, suppose chopper is on. If chopper is on, what will happen? Let's consider in this case all these types. There is a motor or a battery or a back EMF. This is must and should required, especially for class B chopper. In a class B chopper, let's assume that load consisting of a battery or a back EMF. Let's see that this is a load, consists of something or L battery. This, or you want further simplification, you can directly connect as a motor. That's it. This is our operation. Now we will see very simple logic. I will explain the when chopper is on, what will happen. When chopper is off, what will happen. Why the current is negative but voltage is positive. So first instant, you can see that chopper is on. Chopper is on. What I can represent? You can see that this battery or a back EMF or a motor consisting of a voltage. So this is must. Now what will happen when the chopper is on? This voltage will drive the current like this. You can see that current will pass, load goes to the inductor, then chopper, then load. This is the current direction. Now we can see that current, battery or back EMF or load voltage will drive the current. The normal current direction is like this. No, now our current direction is opposite to that. So current is negative. Then what about the voltage? What voltage is 0, because now chopper is on parallel. This is parallel. That's why output voltage is equal to 0. When chopper is on, output voltage will be 0. And now after some instant, chopper is going to be off. Once chopper is off, already again I told no, battery is there. Chopper is off means earlier it is already charged with these polarities, plus and minus. Now it becomes, this is a plus, this one is a minus. Then already there is a E, and this voltage LdI by dt will make forward bias the diode. Whether diode is forward bias or not, now you can see that diode cathode is connected to positive. Then also when the diode will forward bias or any device, if anode is more positive, anode is more positive, then diode will forward bias. But anode is more positive than the cathode. You can see that cathode also positive here. But what is the anode voltage? At this point, you can see that this voltage is E or EB plus LdI by dt. That will makes LdI by dt plus EB is greater than VDC. That's why diode is forward bias. Now current is passing like this, opposite direction. So current is always negative. Voltage is same as now, output voltage is VDC. Voltage is positive. When chopper is on, voltage is 0, current is negative. And chopper is off, chopper is off, current is negative, V out is equal to VDC. That is only the logic. Now over, explanation is over. What we have to do? Let consider load having some voltage source or a battery or load voltage is there. When the chopper is on, what will happen? Current will means voltage source will drive the current through chopper. Then the current is negative. Voltage is 0. Then after that, when the chopper is turned off, load voltage EB plus LDI by dt is greater than the source voltage, then the diode will be forward biased, then the output is same as the source voltage, current is in the opposite direction, then they can say that current is always negative. So that's why we can see that current is negative, voltage is positive, that will give as a second quadrant converter. So this is a chopper, second quadrant chopper. Whenever you require only the second quadrant, then we can see that we can use as a class B chopper. That's what I mentioned here. Let back EMF or a battery must be required and it will rise the current like this. Then we'll get it as a output voltage same as the output from the load side, current will rise that, inductor is going to be store the energy and output voltage will be 0. And then we can see that whenever chopper is off, it goes like this. This is the current direction. Then EB plus LDI by dt more than this. That's why chopper is going to be turn off already, but voltage is there same as the source voltage. Current is negative. Now we can see that waveforms, if you want only small variation, when the chopper is off, you will get it as a output voltage same as the source. If chopper is on, output voltage will be 0. It is just reverse of the type A chopper. So type A chopper waveforms, you can see this is the pulse. Whenever chopper is on, you will get the voltage and chopper is off, you will get 0. So this is the case in the type A chopper. But now type B chopper, when chopper is on, you are getting output is 0 and chopper is off, you are getting output is same as source. This is only the difference between type A and type B chopper. This is also called as a step up chopper. Now we'll see the type C chopper or a class C chopper. The circuit, you can notice very simple logic. It is a combination of type A and type B. So class A and class B parallel, if you do, we'll get it as a class C. That's all. So class C, you can see that the devices are same. Chopper 1 and D1 is nothing but a class A chopper. Chopper 2, D2 is nothing but a class B chopper. Now, how many quadrant operation it will be? So if chopper 1 and D1 is operating, we'll get first quadrant as usual of class A chopper, and here operation will be chopper 1 and diode D1. And then if chopper 2 and diode D2 is on, then if these two are operating, we'll get second quadrant. These two are operating, we'll get it as a first quadrant. So our operation, everything is same as previous only. Now we can see that. Suppose chopper 1 is on. Let's see all of you, just chopper 1 is on. I turn on the chopper 1. How the current will flows? This is the chopper. Now you can see reference and actual is going like this and goes like this. This one. Then what is our output voltage? Inductor will store energy like this. Your voltage is same as the source voltage. Current also positive because directions are same. Current is positive. Voltage is positive. This is a first quadrant operation. Similarly, after that, energy stored in an inductor is there to dissipate. Then the polarities will reverse. This is minus. This is plus. Then it will free wheels through this. Then what will happen? Your output voltage is 0 because diode is conducting parallel with that and the current is positive. Current is positive, voltage is 0. So now from this what is observation? You can whether chopper 1 is on, you are getting as output VDC, and diode D1 is on, output is 0. And both cases current is positive. So that means if these two are operating, you will get first quadrant. Voltage is positive or 0 means average will give positive and current is positive. So this is your first quadrant if these two devices are on. Now similarly, suppose any instant diode is on, diode D2 is on. What is your voltage? You can see diode D2 is on, this is a plus, this is minus, current is passing like this. What will happen? If this is on, voltage is 0. What about the current? Current is negative. Why negative? So it is passing like this. Reference current is this direction and now current is passing opposite to that, current is negative. Similarly, if D2 is on, let's consider diode D2 is on. If diode D2 is on, what is the current direction? See that it goes like this, coming like this, like this. So it is also opposite. But voltage, load is directly connected to the source through diode D2 and D2 is on. What is our output? Vout is equal to VDC. Current I is equal to negative. Then you observe that here what is happening, if CH2 is on, you are getting output voltage is 0 and D2 is on, output voltage is same as source. Both cases can see that current is negative. Then I can represent this is a second quadrant. Now from this it is very clear that if CH1 or diode D2 is on, you are getting as a output voltage same as the source, Vout is equal to source or VDC, and any of these two is on, either this one is CH1 and D2 is on, your output, then CH2 and D1 is on, your output is equal to 0. This is the instant. CH1 and D2, if both is on, anyone is on, you will get the output is VDC. In this either of one, CH2 or D1 is on, you are getting as a output voltage will be 0. So same thing, I will show you waveforms also, simple logic. This is the case. I can mention that CH1 and D1 is on to get the first quadrant operation. CH2, D2 is on, you will get the second quadrant operation. Now, this waveforms you can see that while you are giving firing pulses, CH1 and CH2 should not fire at the same time. Why? If I give pulse like that, the supply will be short circuited. Suppose CH1, CH2 will fire at the same time, then what will happen? Supply will be short circuited. So that is the reason what we will do is should not give the firing pulses. That's why we are giving pulse to the Ig1, there is no pulse to the Ig2. Similarly, if pulse to Ig2 is there, no firing pulse to the Ig1. So like that, you have to provide a firing pulses. Now once if I provide the firing pulses, now we'll see the operation. Now I am giving pulse to the what? CH1. Then what will happen? Thyristor 1 is going to fire. Current will pass like this. What is our output voltage? I told no, either CH1 or D2 is on, output voltage will be source, or CH2 D1 is on, output voltage will be 0. That's why CH1 is on. Now you draw the, what will happen? Current will be rising. So current will be gradually rises and voltage will be same as the source voltage like this. So now you can represent the current waveform as well as the voltage waveform. Voltage will be same as source, current will be rising from this point onwards. This is previous cycle, I will show that after this. So this is the starting point because it is decreasing and increasing. Now from this point onwards, current will be gradually rises from A to B. Current is rising to B. Then what will happen? The firing pulse is over. At this point B reaches, firing pulse to the chopper 1 is over. Means chopper 1 will be off. Then what will happen? Who will conduct now? Because it is already store energy, plus and minus. Now chopper 1 is off. Then what will happen? This polarities will reverse like this. then the diode is going to be forward bias. At this instant, diode is forward bias. So why diode is conducting? Why not chopper 2? Anybody analyze this? Chopper 2 firing pulse also available, but diode is conducting. Why not chopper 2? Anybody? Here the reason is there is a minus is this side and plus is this side. Minus is connected to anode of the chopper and plus is connected to cathode of the chopper. It is a reverse bias. So that's why even though pulse is available, this device will not trigger, and this diode is going to be forward bias and immediately current is passing like this. When the diode is D1 is on, what is voltage I told? 0. That's why I mentioned voltage is 0. And what will happen? Current. Energy stored in inductor, it is going to be dissipated. That's why current will be gradually decreasing. Once the point C reaches, then what will happen? Current pass through the diode is 0. If current pass through the diode is 0, that means whatever energy stored in inductor is going to be dissipated completely. Then inductor is energy is completely dissipated. Then what will happen? Diode will be open. No current pass through that. Now diode is open. Now whatever battery is there, that will rise the current through the chopper 2. So then what will happen? It is opposite direction. The current will build up in the negative. Chopper 2 is on. After diode D1 is open, then the current will build up in the negative. If current is negative, then the chopper 2 is on. That's why voltage is 0. And again what will happen? Whatever energy stored in an inductor, that has to be dissipated. So how will you dissipate it? Because once D point reaches, what will happen? Firing pulse to the chopper 2 is over. See that chopper 2 firing pulse is over once D point reaches. Then the what will happen? Chopper 2, due to forced commutation, chopper 2 will be open. Already it is charged the inductor now, that has to be dissipated. Earlier it is charged plus and minus. Now this one will be plus, this is minus. Then the current will pass through the D2 and it goes to the source and load. So then what will happen? You can see that current is negative, but it is a dissipation mode. Voltage is same as the source. So now that's why we are getting dissipation mode of operation. Once E reaches, then what will happen? This energy, whatever it is going to be driven, and it will be developed in the positive. Again thyristor T1 is going to be 5. So like that, again chopper 1 is conducting, current is going to be rise. So that is the reason after this point we are getting negative. No, that only I represented here, the previous cycle. So very simple logic. You identify if chopper 1 is on, positive voltage, current positive. D1 is on, voltage is 0, current is positive. If D2 is on, voltage is same as source, current is negative. If CH2 is on, voltage is 0, current is negative. With that logic, we can easily explain chopper 1 and class C chopper, first quadrant as well as the second quadrant. So now we'll see the next class D and class E choppers and voltage commutated choppers. So that we'll see in the next class. See, if you are willing, I will take afternoon class also if you want. Afternoon, I think you are free. CR is there? Okay, otherwise I will take on Monday, no problem. Okay, you can leave. If you have any doubt, you ask me, otherwise you can leave.